Objective 2, domain and range of radical functions and their transformations. Alright, in this video we're going to talk about two types of parent functions for radical equations, and that's going to be y equals the square root of x and y equals the cube root of x. So in reference to both of those functions, if you remember, every parent function has the vertex 0, 0, where the x is listed first and the y. So both of the vertexes of each parent function are 0, 0 for the square root of x and the cube root of x. You should have a familiarity about what the graph of both those parent functions look like. I'm going to show you the graph again of y equals the square root of x, but remember, if you need to reference back to another objective to remember what the cube root of x looks like. With this, we're going to talk about the types of transformations and then the domain and the range that goes hand in hand with the vertex. So ideally, the first step is always to identify the vertex in this process, all right? From the vertex, that'll help you find the domain and the range, and you'll also be able to talk about what type of transformation is happening in each process as well. So in this video, I'm going to go through Objective 2, domain and range of radical functions and their transformations. Alright, in this video, I'm going to talk primarily about the first parent function, y equals the square root of x. I'm going to reference the other parent function in this module, y equals the cube root of x, but mainly talk about the square root of x because the domain and range change for the square root of x, that function. Alright, so the vertex of any parent function is always going to be 0, 0. It starts at the origin. So both functions, square root and cube root, have a vertex of 0, 0 as their parent functions. All right? So that's important to keep in mind, especially as we talk about transformations. Now, the equation, the default equation for the transformation function of a radical is y equals the square root of x minus h plus k, where the vertex is h, k. If you remember, to the left term is always lying to you. So in this case, the x value of the vertex, represented by h, is within the radical, and that is always lying to you. So since it's a negative h within the radical, it becomes a positive h for my vertex. So keep that in mind, too, as we go through this process. Now, types of transformations. In this, we're going to talk about 4 different ones: a horizontal shift, vertical shift, we flip about the x-axis, or reflect about the x-axis, and then a vertical stretch as well. So a horizontal shift has to deal with the x value. All right? Vertical shift is the y value. Flip about the x-axis is negative out in front, I'll put, meaning out in front of the function, it is negative, or the function is negative itself. And then a vertical stretch is when the a-term multiplier doesn't equal 1. Alright? So anything but 1 would vertically stretch it. I guess if it's a whole number, it would vertically stretch it. If it's a fraction or a decimal, it would horizontally stretch it. Now, let's talk primarily about the first 3 shifts: horizontal, vertical, and reflect about the x-axis. Alright? That's primarily what you're going to see in this video and in this objective. Now, in reference to the parent function, I did number 1, y equals the square root of x. The first step in this process is to always identify the vertex. This will help you out immensely, so please always reference back to that vertex. In this case, the vertex is 0, 0. All right? Right here. It starts at the origin. Now, the domain, if you remember, is x values, and so we're always going to start with the x value of the vertex. The leftmost point in this case is the x value of the vertex. Now, we're going to include that. It's a closed dot, so I'm going to draw a bracket and have 0. It starts at 0, and then it goes, this function, the root function, goes all the way to positive infinity. So the domain is from 0 to positive infinity. Or you could write x is greater than or equal to 0. All x's are greater than or equal to 0. The range, similar. Remember, the range is the y values, or lowest to highest. And the lowest point in this case is also 0, and we're going to include it because it's a closed dot. And the highest point, this goes right forever, but it also goes up forever, so the highest point is positive infinity. Or all the y values are greater than or equal to 0. So that is the domain and range of the parent function. Now, if I'm going to do an example that's different from the parent function, we're going to discuss the transformation. And again, that's based off of the vertex. And we're going to find the domain and range also based off the vertex. So in this case, if I were to look at number 2, y equals the square root of x plus 1 minus 2, I have to consider what is my h term and what is my k term. And if you remember, the h term is the number left or inside the radical. So this is h, this is k. And if you remember, the h term is always lying to you. So it was positive 1, it's going to be negative 1, comma, k is always telling the truth, negative 2. That is the vertex. So I can plot it negative 1 down to negative 2. And in this case, I'm just going to draw... Sorry, for this case, I drew it accurately based off of the first 3 perfect squares. But for your purposes, I just need a rough sketch that you know that it goes up and to the right. All right, so the vertex was negative 1 comma negative 2, and it goes up and to the right. So the domain, the leftmost point, in this case is negative 1, the x value of the vertex. Bracket that, please, because it's included with that closed dot. Negative 1, and it goes right forever, so positive infinity. And then the range is, the lowest point in this case is the y value at my vertex. So in this case it is negative 2. And then the highest point is positive infinity. And at that point, I am done. That's how I would find the vertex and state the domain and range. Now, you don't necessarily need to write it out, but you should be able to speak out what is happening for this function in terms of the transformation, meaning you should be able to say that this function shifted left 1 space and down 2 spaces for this specific example. One thing I want to point out in your practice, if I'm going to do number 1, but this bottom left one down here. Same thing, I'd identify the vertex. Hopefully you notice the one difference that exists is that negative, meaning it's going to reflect about the x-axis. So the vertex is negative 5 comma negative 3. I plot that negative 5 down to negative 3. Now in this case it usually goes up and to the right, something like that, right? But that negative it reflects about the x-axis. So in this case it's going to go down and to the right, something like that. So I'm going to erase the first one I drew. It reflects about the x-axis, so it goes down and to the right. So that is going to affect not the domain, but the range. All right, the domain is still the same. The horizontal didn't change at all. It still starts at the x value, negative 5 to positive infinity. But if you notice the range, remember range is floor to ceiling or lowest point to highest point. In this case now, this point is lower than the vertex right here. So I need to list that point first. So it flips the range. And this goes right forever, but it also goes down forever. And the down forever is the y value. So it goes from negative infinity to the y value of my vertex, negative 3. And please bracket the negative 3. All right. So this could also be written as y is less than or equal to negative 3. This could be written as x is greater than or equal to negative 5. So just keep in mind when you're working with functions that are negative, they flip across the x-axis and it changes the range. All right. You're all set with this video. You can go ahead and attempt the practice. And again, sorry, to state the transformation, I would say that this function shifted left 5 spaces and down 3 spaces. Thank you.